All right, we'll review 7.2. Okay. 7.2 is integration by parts. Integration by parts. All right. So any question you have on this section, 7.2 integration by parts. Any problem you have? Anyone want to see any problem? How we do any of these problems?
Yes.
Oh yeah. Okay. 33. Okay. So we are doing 33. So exercise 7.2, number 33. Okay. All right. So the question: integral 0 to pi over 2 x cosine 2x dx. Okay, so to do this, I need to make a choice on. Remember that before I do it, the method is this. For the integration by parts, it is integral u dv equal to uv minus v du. Okay, that's the formula. And if I have bounds here, ab, then it will be integral a to b u dv equal to uv ab minus a to b v du. Okay. All right. So the first thing for this integration by parts, we need to determine which one is u, which one is dv. Okay, u and dv. We have to decide which one is which. But if we decide, for example, if I decide on what u is, then dv is the rest. And there are only two choices. One is x, one is cosine 2x. For the u, there are only two choices. There are only two choices. One is x, one is cosine 2x. So I'm going to choose u as x. Okay? So I'm going to let u to be x. Now if I choose u to be x, then dv must be the rest. The rest is cosine of 2x dx. Okay? Alright. So once I choose now, in this setting, I also need to find out what v is and what du is. Okay, so how do I find du? Well, then, if I take du is dx. Okay, because u is x, so du is dx. Now, how about v? V is always the integral of dv. So this is integral of cosine of 2x dx. Okay, and this is equal to, now I'm using a rule, integral of cosine of kx dx is 1 over k sine of kx plus c. Okay, so I'm using this rule. So this is 1 over 2 sine of 2x. I don't, in this setting, I don't need to have a c because I just have to have one v, one such function v, whose derivative is cosine 2x. Okay. So my du is dx, my v is 1/2 sine of 2x. All right, so continue on this one. So therefore integral 0 to pi over 2 x cosine of 2x dx is equal to what? Well, equal to uv, right? What's v? V is 1/2 sine of 2x times 1/2 sine of 2x, and then this 0 pi over 2. Okay? This one. Minus integral 0 to pi over 2. V is, V is just minus 1/2 sine of 2x. Du is dx. So this is equal to, so here I substitute x by pi over 2. So pi over 2 times 1/2 sine 2 times pi over 2. Okay? Pi over 2. Minus, now I replace, I substitute x by 0, so it's all 0. Minus, now this one is 1/2 0 to pi over 2 sine of 2x dx. Right, so I'm going to use, again, this rule. This is a simple rule. Sine of 2x and kx dx is 1 minus 1 over k. Cosine of kx, okay, minus 1 over k cosine kx. So now, okay, so for each term, for the first term, so what this is sine of pi, so this is 0 as well. So I have 0 here from the first two terms. And then this is minus 1/2 here. Sine of 2x, integral sine of 2x is minus 1 over 2 cosine 2x. Okay? And then 0 pi over 2. Okay, so this is minus, okay, negative 1/2 times negative 1/4 cosine, substitute into here, of 2 times pi over 2 minus, okay, cosine, you substitute x by 0. Okay. Cosine of pi is negative 1. Cosine 0 is 1. So this is negative 2 over, so negative 1/2. So that's the final answer. Okay. Any question about this problem? 15. No. Yeah, 15. Any question about this one? Yes. Second? I'm sorry, I couldn't hear your voice. Which problem you have? Which line you have? Here.
Did you integrate sine of 2x dx?
Yeah, sine of 2x dx. Integration this, I use this rule. Integral sine kx is minus 1 over k cosine kx. I use this rule for this here. This is the rule I use for this one. And the one I had before, I use this rule to integrate this part. This one for this one. Okay. All right, any other question? Yeah. 37. Okay, no problem. 37. Okay. So number 37. So it's integral of inverse of sine, okay, y dy, and this is from 1/2 to square root of 3 over 2, okay? All right, so again, remember the formula I have to use is something like this. That's the formula I have to use, okay? So I have to sort of define what u is. Well, apparently, the only u I can use is inverse of sine of y. Okay, so I just have to use this because there's only one choice. this has to be this u. There's no other choice. Okay? Now, so if u is this, then what is dv? Well, dv must be the rest, namely dy. Alright, now, because when I apply the formula, I have this v and the du. So I need to find out what du and what v are. So what is du? Du would be the derivative of this, right? So it's 1 over square root of 1 minus y squared dy. That's the derivative inverse of sine. Okay?
Move it up, please.
Oh, then.
Thank you.
Okay. And then, okay, derivative of u is 1 over square root of 1 minus y squared dy. Okay? And what is v? Well, v is integral dv. So it's integral dy. What's integral dy is y. Okay, so I just use y. Okay. Alright, so this one is becomes what? I have this uv. Right? So uv. Okay, so then this is v and u. This is u. Okay. Minus integral 1/2 square root of 3, right? V du. Okay? So that's what I'm going to do. So let me do the first one first. Okay? Let's substitute y by square root of 3 over 2. Inverse of sine square root of 3 over 2. Minus substitute 1/2, right? Y is 1/2. Inverse of sine 1/2. Okay? And then I have the second one. Let me evaluate the first two terms before I do the third one. Okay? Because the third one I have to do some integration. Alright, so square root of 3 over 2. The inverse, now you can use calculator. Okay, the inverse of sine of square root of 3 over 2 is pi over 3. Okay, you use calculator, it will give you this number. Minus 1/2. The inverse of sine of 1/2, use calculator. Okay, use a calculator. You get pi over 6. So these two are the first two terms. And I still have the third term. And I'm going to do the third term on the next page. I'm going to do this term on the next page. Okay? So how do I do this integration? So I'm just going to do this integration alone. First, do this integration first, and then combine it into here. Okay? So I have y over 1 minus square root of 1 minus y squared dy. So how am I going to integrate this? Well, I'm going to use substitution method. Right? So I'm going to let u to be 1 minus y squared. So du would be minus 2y dy. Okay, so what is this?